Hello, I am Sam Sajis, and my today's presentation is about new efficiency wind technology that everyone need to know. Here is the topic of the presentations: wind energy, wind resources, wind turbine technology, aerodynamics, material, structural mechanics, and new wind technology. Wind energy. Wind energy refers to process of creating electricity using the wind or air fluids that occur naturally in the Earth's atmosphere. Modern wind turbines are used to capture kinetic energy from the wind and generate electricity. There are three main types of wind energy. The first one is utility scale wind. Wind turbines that range in size from 100 kilowatts to several megawatts. There, the electricity is divided to the power grid and distributed to the end user by electric utilities. And the second one is distributed or small wind. Single small wind turbines below 100 kilowatts that are used to directly power a home, from or small business and are not connected to the grid. And the third one is offshore wind. Wind turbines that are erected in large bodies of water, usually on the continental shelf. Offshore wind turbines are larger than landed-based turbines and can generate more power. Wind resources. Here is the keyword for wind resources. There is difference between the wind profile during the night and during the day. The smallest form for the wind profile is so-called logarithm wind profile. If we consider a high friction as Z, we can see the equation U Z equal to W naught divided by K into ln into Z divided by Z naught minus Y. Here the U equal to wind speed and U naught equal to the friction velocity, and K equal to the Kármán constant, and Z is the height, and Z naught equal to the roughness length, and Y equal to atmospheric stability function. In natural condition, the stability function is 0. We can purely logarithmic profile in natural condition. Natural condition means there is no heat flux. So the condition overcast with high wind speeds, and it varies with geotrophic wind. Geotrophic wind is a wind that drives near the surface, and the sunny day profile is larger than the natural wind profile. As the wind speed reduced near the ground, to get and increase the fairly fast with height about 100 meters. It also varies with the surface roughness. As sea condition, the surface roughness is very low. But another place, the forest. The forest has lower roughness than a spare forest. So it increases during the day because you have the convection that stirs and have the coefficient mixing of the energy. And the water condition, you don't have to heating the water and cooling the water during the night and heating during the day. It's very clear that there are random variations of wind speed in times. There are two measuring tools for wind. The first one is cup manometer. The cup manometer is the rate of rotation is proportional to the wind speed. And the second one is sonic anemometer. This is more reliable instrument to measure the fluctuations of the air measure of the fluctuations of the air particle at the smallest time scale. Wind technology. Here is the keyword for wind technology: rotating leaf-based mechanics, rotating drag-based mechanics, flying leaf-based mechanics, and mechanics using flow include vibration. We all know the horizontal axis wind turbine, where the energy form of the wind is extracted from a rotating shaft parallel to the wind. Is rotating due to the lift force on the airfoils of its blade. The blades are rotating in a horizontal plane and also driven by lift. Where the shaft is vertical, it is called vertical axis wind turbine. Another typical vertical axis turbine is the drag-based turbine, where the drag on one side is larger than the drag on other side, and therefore that creates a moment that makes the shaft rotate. The flying leaf-based mechanics, one of them is the kite that pulls a cable, then pulls the generator that is mounted on the ground, and the last one is the mechanics that using the flow include vibration is the last category. Altogether, we get the result of this technology. The mechanical power from any concept can be calculated from the air density, the swift area from which the energy is exerted of this wind, the wind itself Q, and the power coefficient. The wind turbine exerts the energy form, the momentum from the wind, which slows down the wind speed, and the swift area. It is there are two areas in, and one is in front of the blade and other is in behind of the blade, is passing through the blade. Let's consider the wind turbine. When the energy exerted in the bottom of the turbine instead of up at the top, then the tower, the energy goes to the generator and also bring the energy from the bottom. The transmit the electricity generated through the cable to the ground. The last one is to flow include vibration that can generate electricity by making a beam vibrate and piezoceramic metal that are exact the energy. The main components of wind turbine. Basically, there are three main components. The one component is the rotor, another is the nacelle, and another one is the tower. Rotor. Rotor generates the aerodynamic torque from the wind. The rotor blade wind turbine operate under the same principle of aircraft wind. And the nacelle. Nacelle convert the torque into electric power. And the tower. The tower hold the nacelle and the rotor blade up in the wind and provide access to the nacelle. And the main degree of freedom. The main degree of freedom, yeah, there are one is ear motor and one is ear drive. Ear motor is driven by ear drive, and ear is used for rotating the nacelle about the vertical lengthwise axis of the tower. And pitch is rotating the blade about their lengthwise axis due to the pitch control. And rotor is with blade and half spinner, pitch bearing and system. And the final one is nacelle. Nacelle is drive the main bearing, gearbox, brake and generator. And it also helps the power electronics consisting of converter and transformers. Aerodynamics. Power, thrust and optimum rotor. 1D moment theory for the wind turbine. A wind turbine is a device which is made to extract energy from the wind. It does so thinking other kinetic energy. The wind loss velocity as it passes through the turbine. The flow through the rotor. The role of this rotor is to stop the wind not fully, but enough to take out some kinetic energy. So we can go into the power. When we look at the 1D moment theory, we can assume how much power can extract from the wind. So we know the Bernoulli's principle. Here is the Bernoulli's diagram. The falling velocity leads to bigger pressure, so the pressure has to increase until gets the point of the rotor. Over the rotor, there is a drop in pressure. The pressure recovers at atmospheric pressure again, and that also means that the velocity helps falling until it back at the atmospheric pressure. This is something we analyze with the Bernoulli's equation. The equation states that you can follow the sum of pressure and one half velocity squared in constant. So if we form to the start, then to the start of the rotor, we would have that the initial term here equals P plus and one half rho U squared at the front of the rotor. Then back to the rotor and to the in. We apply Bernoulli principle here. We would have the same pressure, but now when the pressure drop include the same velocity term that here, and then it is the far end. We would say P naught plus one half rho is U1 square. And now by subtracting the equation, we can actually derive an expression for delta P. Here is the expression of the delta P from P naught to delta P. We can also able to utilize mass conversion because of A and V equal to rho A1 and U1, which also equal U times A times rho, and which is 59% of incoming kinetic energy. Materials. For wind turbine, we have to consider about the materials. The materials property is basically equation for the stress and strain. Such like if we consider a rod length L naught metal, A naught is the section area. So if we apply the force in the rod become longer and thinner. The engineering stress is calculated by dividing the force with the original shear stress area. And strain is calculated by dividing the increase in the length with the original length. And here is a curve of the and here is a curve of the strain stress. Here is the yield stress, and this is the plastic deformation point. So the linear relationship between the stress and the strain is this known as Hooke's law, where E is the modulus of elasticity and corresponding to the stiffness of the material. So the stiffness is basically the slope of this line here. The stiffness is related to how strong the atomic bonds are, and this is also related to the melting point. So all the iron-based alloy that will have a roughly the same stiffness, while all aluminum-based alloy they have roughly the same stiffness. And if we want to change the stiffness, we need a major change in chemical composite. And if we want to increase the stress, then we will reach a certain point called the yield stress. Yield stress, and this is the point of the yield stress. And the metal that consists of metallic atom that are fixed in a crystal lattice. If we apply a low stress of a lattice, then we will stress it, and if we relax the stress, when we will, the lattice will revert to its original shape. And if we reach at the yield stress, we will actually break the atomic bond. So this is called plastic deformation, and this is permanent. Structure mechanics. For wind and a turbine, we have to measure the structure mechanics. We have to consider about the loads, the boundary condition, and structure requirements and failure. Suppose as an example, a tennis racket. What are the loads? The loads come from the bat hitting the strings in the racket, and the boundary condition comes from the player grip on the tennis racket. But it can fail. In this case, it failed because of a player hit the racket to the ground. So for the wind turbine, we have to consider about the equilibrium, and we have to and find the force and moment, and we have also considered about the support and calculate the displacement and force, and also calculate the reaction force and internal force. The new wind technology. Here we can see two pictures that people are using the wind technology in their house. Sky wind, NG micro winds are powering homes, equipments and telecommunications around the world. And air patented all metal constructions offer outstanding durability and power output on. And on the offshore platform, it might the future of the wind to start generating clear and affordable energy from our rooftop. It's a low weight and small dimensions of a single unit, and also allow for easy transport and installation anywhere in the world. Finally, wind energy is the future and the future of energy concept, and for reduce the pollution of the environment. That's all my part. Thank you everyone.